China's rise as a global superpower has been accompanied by significant advancements in its military capabilities, most notably, its nuclear arsenal. While the world has focused on the increasing size of China's nuclear stockpile, a far more concerning development has flown under the radar: China's mastery of adjustable yield technology for its hydrogen bombs. This breakthrough gives China an unprecedented level of control over the destructive power of its nuclear weapons, raising profound implications for global security. China's pursuit of nuclear weapons dates back to the Cold War, driven by a desire for security and international prestige. After successfully testing its first atomic bomb in 1964, China quickly shifted its focus to developing the far more powerful hydrogen bomb. The H-bomb, also known as a thermonuclear weapon, derives its explosive power from the fusion of hydrogen isotopes, unleashing energy on a scale unimaginable with conventional explosives. China's successful test of its first H-bomb in 1967 marked its entry into the exclusive club of thermonuclear powers. However, early H-bombs were massive and unwieldy, with yields measured in megatons, capable of obliterating entire cities in a single blast. These early weapons were seen as strategic deterrents, too powerful to be used in anything but the most extreme circumstances. Over the decades, China has relentlessly pursued advancements in its nuclear technology, driven by a desire to match the capabilities of the United States and Russia. Chinese scientists and engineers have made significant strides in miniaturizing nuclear warheads, making them compatible with a wider range of delivery systems, including intercontinental ballistic missiles and submarine-launched ballistic missiles. This miniaturization has allowed China to develop a more survivable nuclear deterrent, less vulnerable to a first strike. However, the most significant development in China's nuclear arsenal is its mastery of adjustable yield technology. This breakthrough allows Chinese military planners to fine-tune the explosive power of their H-bombs, selecting the desired yield depending on the target and strategic objectives. This level of control over nuclear weapons was once considered the stuff of science fiction, but is now a chilling reality. The ability to adjust the yield of an H-bomb stems from the complex physics of nuclear fusion. Unlike fission bombs, which rely on the splitting of heavy atoms like uranium or plutonium, fusion bombs initiate a chain reaction that fuses lighter hydrogen isotopes into heavier helium atoms, releasing immense energy in the process. This fusion reaction is highly sensitive to variables such as temperature, pressure, and the presence of certain isotopes. By carefully manipulating these variables, Chinese scientists have gained the ability to control the efficiency of the fusion reaction, effectively dialing up or down the explosive power of their H-bombs. This precise control over yield offers several strategic advantages, blurring the lines between strategic and tactical nuclear weapons. Traditionally, nuclear weapons have been categorized into two broad categories: strategic and tactical. Strategic nuclear weapons, like the massive H-bombs developed during the Cold War, are designed to inflict maximum damage over a wide area, targeting cities and industrial centers. Tactical nuclear weapons, on the other hand, are smaller and more precise, intended for use on battlefields against military targets. China's adjustable yield technology blurs the lines between these categories. A single H-bomb can now be tailored for a variety of missions, from destroying hardened underground bunkers to taking out an aircraft carrier group at sea. This flexibility gives China a wider range of options for employing nuclear weapons, raising concerns about their potential use in limited conflicts. Section 4. The Science of Controlled Destruction. The scientific principles underpinning China's adjustable yield technology are shrouded in secrecy. However, experts believe that China is likely employing a technique known as dial-a-yield, or variable yield. This technique involves manipulating the amount of fusion fuel, typically lithium deuteride, present in the secondary stage of the H-bomb. The secondary stage of an H-bomb is where the fusion reaction takes place. By varying the amount of lithium deuteride, Chinese scientists can control the number of hydrogen atoms available for fusion, directly influencing the explosive power of the weapon. This fine-tuning allows for a wide range of yields, from a few kilotons to hundreds of kilotons, effectively bridging the gap between tactical and strategic nuclear weapons. The development of adjustable yield technology is a testament to China's growing prowess in nuclear physics and engineering. This breakthrough has significant implications for the global balance of power, as it gives China a more credible and flexible nuclear deterrent. Section 5. Shifting the balance of power. The ability to precisely control the yield of its H-bombs enhances China's nuclear deterrent in several ways. Firstly, it allows China to respond to threats in a more graduated and proportionate manner. Instead of relying solely on massive retaliation, China can now threaten a more measured response, potentially deterring adversaries from escalating a conflict. Secondly, adjustable yield technology makes China's nuclear arsenal more survivable. By deploying a mix of high-yield and low-yield weapons, China complicates an adversary's ability to neutralize its nuclear forces in a first strike. This survivability is crucial for maintaining a credible deterrent, as it ensures that China can retaliate even after absorbing a nuclear attack. The strategic implications of China's adjustable yield technology extend beyond its immediate region. As China's global influence grows, so too does its ability to project military power around the world. This has raised concerns among some of China's neighbors and the United States, which sees China's growing military might as a potential challenge to its own dominance. Section 6. A world on edge. The development of adjustable yield technology has also reignited the debate over the role of nuclear weapons in international relations. While proponents argue that nuclear weapons serve as a deterrent against large-scale conflict, critics point to the risks of accidents, miscalculations, and the potential for escalation. China's growing nuclear capabilities, coupled with its assertive foreign policy in recent years, have heightened anxieties about the potential for a new nuclear arms race. The United States, under the Trump administration, withdrew from the Intermediate Range Nuclear Forces Treaty, or INF Treaty, with Russia, citing China's growing arsenal of intermediate-range missiles as a justification. The collapse of the INF Treaty has raised concerns about a new era of nuclear competition, with the potential for destabilizing arms races in Asia and beyond. The lack of transparency surrounding China's nuclear program further complicates the situation, as it fuels mistrust and suspicion among regional powers. Section 7. The future of global security. China's mastery of adjustable yield technology for its H-bombs marks a significant milestone in the evolution of nuclear weapons. This breakthrough grants China an unprecedented level of control over its nuclear arsenal, enhancing its deterrent capabilities and blurring the lines between strategic and tactical nuclear weapons. The implications of this development for global security are profound and far-reaching. The international community must engage in dialogue to address the challenges posed by China's growing nuclear capabilities and to prevent a new nuclear arms race. The future of global security may depend on it.